Welcome back to Incremental, the continuous improvement podcast. This is our practice edition where we discuss improvements from the week and the lean principles behind them. I am Uriel Eisen.
And I am Devin Bedoni.
You got a quote?
Yeah. You don't have to hit hard to hit a home run. If you have the timing, it'll go. From Yogi Berra.
So to your point that you just said a minute ago, not sure if you're using steroids.
More like the prevalence of steroid use would argue the opposite, but...
Yeah, maybe hitting hard can make up for poor time. Or probably also not true.
Also not true,
It's helpful to hit hard and with good time.
I think it's more, if you have amazing timing and steroids, you're going to hit harder. It's going to go further.
Right. But...
Is that overwork or overprocessing? If it goes over the wall, that's all that matters.
That's true. Any extra distance is just waste. But for the purposes of this podcast,
yes,
I guess the power is maybe sort of like heijunka, like production like working too hard or too slow instead of just getting your timing right.
Yeah,
would be
or
one way of looking at it.
Yeah, that or just like, the classic, like slowing a machine down to stay in step with the other parts of the process.
Slowing a machine down to speed up your end-to-end throughput.
Yeah.
Which is weird, but real.
Right. Having things finish when they are needed, not before.
Yeah.
Not after. It applies everywhere.
It does. So we have, did a lot of improvements this week.
I see that.
Also... Maybe we start with the lean wastes.
Yeah.
So we have overproduction, overprocessing, excess inventory, defects, transportation, wasted motion, waiting, and wasted human potential. Amen. So here's one. We are doing these long straps. I think we posted it to the stories and incremental
for a particular
CI.
customer.
Custom straps. They're 18 feet. Normally we do ones that are 4 feet or less.
Yeah.
Partly we took it because we've been getting a lot of requests for longer straps, and so kind of wanted to refine our process, to start figuring out how to do that efficiently.
Yeah.
So we were winding up. What we found. So the issue is to package them. We wind them up.
Oh, yeah.
And if you sew your buckle to one end and then you start winding from the other end, you need to make sure that you're winding such that the buckle will end up oriented correctly when you get to the end of the spool.
Because you put the tail through the buckle, or just so it looks right? So it looks right. Okay.
Yeah.
Yeah.
And so that's a lot of bother. So what we found worked best was winding up the webbing to begin with. It made it easier to transport from where we cut it to which is 90-degree turn, wind it to begin with, leaving a tail. And then we tucked it in this bin that would sort of hold it while you sewed, and then finish winding by hand. And then after doing a bunch that way, we realized it was over processing to pick up the spool of webbing off of the winder, put it down, only to pick it up again and move it another time. And so we built a little flip-up clamp that holds, so you can wind it onto the winder, leaving a tail, flip up this clamp, which holds it there, sew the buckle on, and then continue winding on the winder. And so that eliminated picking it up, moving it, tucking it in this bin. So that was kind of a win. Reduced... I would say overprocessing was the biggest one, wasted motion, and then I guess also wasted human potential in that it eliminated the step of then hand winding the last couple, the last 2 feet that you needed. You needed some slack to sort of get it into the sewing machine right.
Yeah.
If that makes sense. And so, so that was a nice one. We did it super fast, probably we noticed the problem and then probably took 10 minutes to get it working. And that was just we grabbed a door hinge, cut a piece of plastic we had laying around, screwed them together, covered the ends of the screws with some E-tape so you didn't hurt yourself on them. And then the spring was just a piece of rope with a box of screws hanging from the end to kind of pull it against it.
Yeah.
It's still set up that way, you know. And then there was an issue of like not having enough hands to hold the clamp down. Like it was annoying. The clamp kept flipping up.
Oh.
Like even when you're trying to get the spool off or whatever, you know, the webbing off. And so we added a little piece of spring wire like to make a little latch kind of, so it would stay down and then you'd bump it with your wrist and it would pop up. And so it's super rough, but quite effective, and it will kind of inform how we build our winders moving forward, I think, because that seems like a really useful function. So
this was primarily for reducing over processing.
That's sort of what we noticed. Yeah. We were trying to shave, just make that task easier, more efficient. And it was like, wait, we're picking that, like we're just watching the webbing. It's like we're picking it up another time. Yeah. Can we eliminate that?
Have you ever considered like pulling the webbing, like sewing straight from the reel and then cutting after?
Yes.
I know there's probably some real issues there, but
issues. Be here all night. We have thought about it. We haven't really come up with a good way of doing it, I guess. And I don't know what the advantage is. I mean, it seems appealing.
Right.
I'm not sure why.
Yeah. I think in my head, I'm like, well, if you had it all laid out properly, there would be no additional handling of the webbing.
You know, that would probably actually be a really good step toward complete automation. Because you have, I don't know if it super matters. Because one way of looking at it would be that you would have more, fully constrained.
Right. You'd have to set up your webbing in a way that it didn't require like a lot of hand touch.
But then simultaneously, you could also say the sewing and the measuring and cutting could happen simultaneously if
they were separate.
If they're kind of separate, I don't know.
Mm-hmm. That's sort of like what's the end goal, automation or simultaneous processes, or both.
Yeah. Both.
Always both. Interesting. We had a small one, so kind of the issue was, so most of our work right now is in the kind of like outdoor sports, adventure sports industry.
Okay.
Or, which this kind of falls into it too, but like some aftermarket stuff for trucks. It's kind of adventure sports as well.
Yeah.
The key piece being here that most of the industries we work in don't require inspection reports and material certs. They're just kind of like, make the parts good. As long as they're good, we don't kind of care.
Yeah.
Get them quick, make them good. But we started doing some work for a company that does oil and gas research. They're based in the UK. They have very stringent requirements. And kind of what happened basically was like, we made the parts. They were on a short timeline. I was going to deliver the parts the next morning, and I got the email like, just making sure you've got a material cert and a full inspection for each part, and that they're marked with their serial numbers. And we were like, oh, we just completely missed this because I didn't read the PO fully. I read the top part where there was like quantity and, you know.
Yeah.
And then there was a whole lot of communication that had to happen internally in our shop to like get all this stuff together. So basically it was, I don't know, over-processing, I guess, maybe as well, was kind of the issue we were seeing, all this excess discussion and communication. And the not workaround, but the fix, the improvement was just to change our work order slip so that it has a checkbox for if we need to do material certs and inspection reports for a part.
Interesting. And you were serializing just on the laser, or how are you?
Yeah, on the laser.
Is there a good function for that, or that's just a manual change a digit, hit
it was
go?
Only two parts in this case, so it was like...
Did you serialize them 1 and 2?
No, they had like a 6-digit number.
Oh, they provided one.
They provided serial numbers, yeah.
That makes sense.
I was a little, like the example had like, they sent like, you know, an engineering document along with it that it was like, this is how you do this stuff, this is how you do this stuff. And the example was like, just take the part number and put it in with the serial number. And I was like, well, that doesn't make any sense. Is that what we're supposed to do? And they were like, no, the serial numbers are provided on the purchase order. But anyway, so it was has been very cool to have this like work order slip that we can just like edit and change as we go to suit our needs. And this will still require that someone obviously read the PO thoroughly for this type of work. And I think mostly it caught us out because we hadn't done a lot of this before. And the kind of like the owner called me personally and was like, yeah, just go for it. Like, we need these parts next week. Just make them.
Gotcha.
And then like the PO came later and
they're like, ignore the owner. Here's what we need.
Yeah, basically.
Yeah.
Yeah. Don't listen to him.
Yeah. He doesn't know. We know.
Yeah. So a small improvement hopefully will reduce.
That's cool.
A lot of overprocessing and defects potentially if you consider delivering a part without the necessary documentation of defect.
Yeah. It's making me wonder. It's making me think how we could apply serial numbers, because I've been wondering about like supply chain traceability internally. Right? If we need to do a recall for whatever reason, hopefully not.
Yeah.
We don't know which buckles came out of which batch of materials, et cetera, et cetera.
I'm sure there's some simple software for laser markers to do serialization very quickly.
I would think so. And I'm just thinking how that would get added to our process. And I don't think it would actually be too difficult.
No.
I think you basically queue up the next parts you're going to assemble in one fixture that holds them such that they can all be serialized.
Yeah. You probably have a dedicated laser in the assembly station that was just for that.
Yeah. And then once we're at it, it seems like adding logos and stuff would be minimally added work. Yeah. Potentially.
For sure.
We finally finished a pull tester.
Yeah.
So that's mostly an R&D improvement.
Explain what that is for people who might not understand.
It pulls things to test them. No. So it's basically ours is a large hydraulic cylinder, and then a load cell. And so you can pull things like destructive testing or pull them to a particular load and make sure they hold repeatedly or whatever.
Yeah.
There's, companies that build, they're called universal testing machines. Yep. And they give you they graph out sort of elongation, and it's called a stress strain curve.
Yep.
And that's all very interesting. They're just very expensive, and especially at the loads we kind of want, they get more expensive because we're actually going to decently high loads. So this is sort of, we've had a pull tester in the shop. It was manual. It was annoying to use. And because it was annoying to use, it kind of only got used when necessary. And I think this is going to be a great learning tool. I have some ideas on improving the geometry in the buckle and also working on some new applications and stronger buckles. And so just having that really fast feedback loop of, you make something, you walk over and make it explode, sort of see what the load is. There's a lot of complication around kind of, I don't know exactly what to say here, but like data is cool, but it's actually not necessarily super useful. It's not as directly useful as one might think. So like, this buckle broke at this load. What does that mean? And if you do another buckle, is it the same load? And then how many do you need for that to be significant where you say this is the...
Right. It's the difference between generating an actual thesis and proving it, or like a scientific, using the scientific method versus just breaking things.
Yeah. And so... and like, what does each test really tell you? All that. So it's been really interesting, and kind of just excited to be able to break more things and see how they break.
Yeah.
Yeah.
So you're going to develop like a test regime that you can standardize across all your buckles, basically?
That would be the thought. Also kind of understanding like what it needs to be, to get to offer a load rating.
Right.
On
There's
buckles.
Probably standard regimes you have to follow already.
Yeah. And I think for like DOT, rated stuff, it's actually pretty minimal. But yeah, so it's a mix of learning tool and then sort of like validation tool, I guess. So what is that? Trying to think like the wastes that we're seeing by not having it. I guess defects would maybe
sort of.
like making sure that we're still in the,
I think trying to place this lens on it is a little bit like really what this is like a tool to allow you to expand into new markets.
I guess so. It's also sort of a learning tool for R&D.
Yeah.
Maybe reduce weighting. Maybe that's what it is, of getting test results or something. I don't know. Anyway. Yeah.
Interesting. So Monday, I spent a whole day.
Yeah.
Finally doing a first test of using G54.2 probing from CAM and
It's a mouthful.
cutting apart with code output from CAM.
Okay.
So I'm trying to figure out how to break this down in a way that for the non-Uber nerds.
Yeah.
Even most machinists don't really know what G54.2 is because it's pretty weird niche. The long and the short of it is, and I maybe described this a little bit last time we talked about it, when doing rotary fourth axis work right now, I have to program from center line of rotation for two of the axes, for the axes that it rotates around, or the axes that are not the axis it rotates around. It rotates around the x-axis.
Yeah.
So that one can be anywhere along that axis.
The 0.
Yeah.
Yeah.
The 0 point for the other two have to be at that axis. Right. Otherwise, they shift when it rotates, and the machine doesn't. The program doesn't orient properly to where the new point is. So what G54.2 does, it's sort of similar to like Haas dynamic work offsets. It allows you to set your origin at a point that is not the center point, and then the machine will recalculate based on a rotation when it moves and reset all those 0 points basically based on that rotation and vector. So that's a bit of a mouthful. Anyway, the implementation is really in the machine is totally good and fine, and it's just been a CAM code issue.
Yeah.
So
CAM is basically
computer aided machining.
Yeah.
I've had this like option on the machine for like 2 years, and I've never used it because it's always been a thing where it's like, if I want to try and use this, I'm going to have to do a lot of manual code editing.
Interesting.
But there's a couple key things, key points or places where it's going to be really helpful, I think.
Okay.
So the first is just allowing us to standardize setups for 3-axis and 4-axis jobs. So like they can always have the same origin. And that's maybe most important actually because it allows us to standardize our CAM template. It will be simpler for operators as well to set up a part.
Yep.
But more important, I think, is standardizing the CAM template. And then if we're moving into automation stuff, there's a lot of times, as you know, where maybe a gripper will drop a part onto a jaw.
Yeah. And
it may shift a little bit. And this will allow us to compensate for whatever those shifts are, or test for out of position, because we'll have an origin that actually like relates to the stock.
Okay. Right, without doing manual coding.
Yeah, basically. We can be like, okay, this is where the stock was. Now you can go probe and check to make sure it's still there.
Yeah.
Versus being like, this is a theoretical point in space that has no real relation to the stock. Do a bunch of math to figure out where the stock's supposed to be, then write a probing routine to check if it's where it's supposed to be.
Yeah.
Now it's just kind of like, well, you probed it here last time. Is it still there?
Yeah, I think you can right now, like I can validate position right out of CAM, but I can't adjust for that new position. I could just stop the program.
Yeah. But could you do it if it doesn't relate to your part? Like you couldn't do
Yeah.
that for Z, could you?
No, yeah. So you can just do probing, like driven off of whatever your origin is.
Yeah.
And then you can set a deviation, an allowable deviation from that to throw an error.
Right.
So,
but if it's not at the point that you're probing, like if Z is center line of rotation and your part is 4 inches above that.
Yeah. I select the face in cam.
Yeah.
And tell it to probe that face. And it's all driven off of whatever the origin is. Like it doesn't have to probe at origin.
And does it function right now? I've talked to different people that said that function is not working with the Bloom routines. Is it?
I thought so, but maybe I'll check. I don't know if I've ever had it throw an error. I have had it validate stock placement, not at the origin.
That's good to know.
But it's a good question if it would have thrown I'm trying to think if I've had it throw an error. Like when I do manually loaded vices, if I'm doing multiple parts, and I don't have a mechanical stop, I'll validate it. Anyway.
Cool.
And interesting.
Then, the other big benefit will be for second operations, which basically right now, if you're probing from center line and you build a fixture or you cut a soft jaw, if that fixture or soft jaw is off at all and you need to update it, you either have to rebuild it in cam to reflect real life, which can be a bit of a process just to figure out what that is, or accept the parts as they are.
Yeah. Cut a new soft jaw.
Or cut a new thing
in place.
Yeah. And so this will allow us to just make little compensations where we're like, okay, it's 5 thou too tall.
Yeah.
We're just going to move the origin down 5 thou in Z. It will still compensate correctly when it goes to A90.
Right. And I think the key here is that all of this stuff is all possible without any of what you did.
Yeah.
It's just that now it's so easy.
Right.
And there's essentially no added work to implement it on every new part. And you do a lot of new parts. Like I have sort of workarounds for all this.
Right.
Like I use G58 for me is the center of rotation. I write that to G57 and G59. And then when my parts move, I write a compensation manually that stays with the program.
Yeah.
So I guess the advantage of the way I'm doing it for like production where you're switching back and forth from parts is that the compensation lives with the program, and you don't need a probing routine, but the time savings there is minimal and the work involved in adding that. I mean, now that I have the code written, I just copy and paste it to new parts and set all the compensation to 0. The other thing is it sort of assumes I've been able to do it because all of my machining on Op2 happens either in 3 axes or sometimes there's a turn down to 90, which doesn't, I mean, I've just made sure that it doesn't have an effect. But for you, like flexibility is so important. And for me, flexibility would be helpful probably. I'm sure if I had it.
And there's lots of use cases where it's like, if you're just rotating to A90, the math is very simple.
Yes.
If you're rotating to like A46.3 and then you have a face that you're face milling at that and it's off in one direction but not the other direction, like it starts to become kind of complicated to interrogate what that issue is and how to solve it.
Yes.
So hopefully this will help with that. And it is kind of a bummer that if we've had to put in all this work to make this a functional thing, because there is a lot of like machine and cam scenarios where this would just be plug and play, more or less. Like Haas, like other post processors for other machines that use G54.2.
Yeah.
That being said, I think it's going to be worth it in the long run to simplify our whole workflow, basically.
And to zoom out a little bit and generalize this, I think the cool part, watching it from the outside, is it would have been very easy to just and you've been doing that for years, of every part that comes through the shop, you reprogram. And I think it takes a certain awareness, and this is sort of the whole point of continuous improvement, to look for things.
Not program. I have to program every part that comes.
You have to
the
program every part,
Yeah.
and that is sort of labor intensive, and there are ways around it, but you really have to take the time to add like template toolpaths, build CAM templates,
Yeah.
like all this standardization work, and there's huge upsides, but it's really easy to just sort of accept what is and try to muscle your way through, or hire more people to do the same sort of crappy process.
Yeah.
Yeah. So, I mean, taking the time to hopefully refine those processes is, in the long run, huge efficiency gains.
Yeah. Yeah. Another place where this will be beneficial is like, say we cut a fourth axis, second op soft jaw on one machine. We need to move it to the other machine. The axis, like the rotary axis offset of the trunnion is not identical. This should allow us to compensate. Like, the more I start to think about the use cases, the more I'm like, this is absolutely going to be a huge win. Yeah, and it's just a bummer. It's been such a hassle to get.
Yeah,
if
you think about the math behind it, it's not nothing. I mean, like if you're doing surfacing at some odd rotation, like it's not just shifting X and Y. It needs to know how much they rotated into, like how much Y commands translate into, Z move, like Z position. That's kind of cool. I mean, it's simple math. I think this is all like linear algebra and matrices and...
Yeah, it's just a lot of calculations at one time, I think, is what it is.
Interesting.
Like, I think it's simple math, but it's processor heavy, and that it's doing a lot of, well, I don't know, but for sure, but it's doing a lot of calculations, overlaying a calculation on every calculation.
And is that mostly done in the control, or is a lot of the post outputting the correct, like different toolpaths?
Control.
Okay, so it's doing the
posted code is only different in one line. Basically, it says you use this as your reference work offset.
Yeah.
And use this as your actual work offset.
Okay.
All the other code assumes that you're going around center of rotation.
Interesting.
So the control is doing all the compensation.
Very cool.
Yeah, it's kind of wild.
Let's see. So another one we have is we finally added Kanban to our 3D printed automation parts. So they deteriorate pretty quickly in the coolant. That is a separate problem that we are trying to solve as well.
Pretty quickly? I thought you were getting like 6 months.
No. Recently it's been more like, I feel like a month.
Huh. I wonder if that was a difference in filament issue or coolant concentration, temperature.
Yeah. I'm not sure. Maybe we're noticing it faster now.
You doubled your throughput.
We did. Yeah, there was that. Yeah, maybe it stresses over time. Anyway, so we ordered some other plastics to test, but regardless, those two will wear out and need to be changed out. And so it's always, or we crash the machine or something happens and we need a replacement set.
Yeah.
Instead of realizing that and then needing a 2-hour print to have replacement parts, now we just have a backup set always there.
Yeah.
And now there's a Kanban. And now that Kanban gets circulated back to the 3D printer, which calls for production of that part. It's something we've sort of been moving to. I feel like we've pretty much implemented Kanban on all kind of like, I don't know how to talk about it, but like tier 1 parts, right? It's like, do we have enough stock? Do we have enough paint? Do we, like the stuff we kind of make,
like
the
stuff
that
goes
ships,
under cost of goods sold.
Basically. Yeah. And I don't know why that's sort of what I thought of immediately. Like we do have a lot of other supplies in the shop, like paper towels.
Well, I think it's because those are the things that stop production, like hard stop.
Yeah, it's like you have no more parts to machine. Yeah. But suddenly, and I think this is sort of a big misunderstanding of sort of JIT. Everyone's like, that's why our, economy ground to a halt, or our supply chains ground to a halt with COVID. It was because of just in time, and it's like that's sort of true. But the counter argument to that is that companies that practice just in time at a really high level are constantly trying to figure out what the next thing is that could interrupt their production and how they're going to prevent it. So like one shop tour I saw, they had a contingency plan written on every machine that was like, if this machine goes down, here is our plan. Right. And they thought about that ahead of time. They didn't wait for it to happen to start putting that in place. It's like, here's who you call for replacement parts. Here's like, there's just like a lot more riding on fixing the problem. And so you want to get out ahead of it.
Yeah.
And so what we've started seeing is just like how those failures cascade through your shop, and the disruption can be massive.
Yeah.
And the cost of the thing that led to that disruption is, I mean, in this case, literally $6, $7, right? And you know, we have assembly fixtures that we don't have replacement parts for, and they're all 3D printed. So it's like pretty silly. But again, it's another thing to track. And so it's been really like finally having a Kanban system for 3D printing, I think is going to be a pretty fun improvement like across the whole shop. How
are you handling the file storage for that?
Yeah, we don't have so the way we've handled it so far is I built a file structure. This isn't a good way, but this is what we're doing. Each I have a 3D printing file, like folder, and then in that folder we have different parts, like 1-inch cam buckle, and then you're like, okay, it is associated with 1-inch cam buckles, so I'm gonna click into that, and then it's like you go into the 1-inch cam buckle body, and then it says like gripper fingers, and we have a file sitting there for the gripper fingers.
I mean, it'd be kind of a little bit wasteful, but you could almost just like buy an SD card for each
so we talked about this previously, I think, on the podcast, and someone wrote in that that was my plan, because it seems like sort of wasteful but also pretty awesome just to like pick up an SD card, plug it into
well, I mean,
to the races.
You could actually put it
on the
actually
Kanban.
Attach it to the Kanban.
I think that would be awesome. The person who wrote in, which I think is a fair point, though maybe doesn't mean we shouldn't do that, is that like the single point of truth issue of like the design gets updated and then you need to make sure to go get the SD card. Whereas if it's a file structure, like I was thinking maybe a nice workaround is to have a QR code on the Kanban. When you scan it, it takes you to that file on the computer, which I think with like Dropbox, it was the implementation I'm thinking of now. I can generate a link to a folder, and so I think using Dropbox I can pretty easily add a QR code that takes you directly to the file you should print.
Interesting.
We just ordered a Bamboo 3D printer, which you can print over Wi-Fi reliably. I know you can do it with other printers. I've not found it to be reliable or worth the struggle. And so I don't know if that changes things. Like that might make it easier because you don't have to put it onto an SD card. I'm not sure. Anyway, that is still a question, but
interesting.
The Kanban feels like a mental load that's been lifted. If you find yourself walking around your shop, looking around at your supplies, going like, okay, do we have enough of this? Yes, cool. Do we have enough of this? No. Oh, I better order more. Like that is where Kanban comes in, and it is a huge amount of work that you're not thinking about walking around your shop. It's all waste, and it's solved. The way we solved it is with index cards and a Sharpie. Like if you look online, there's examples of like, we built this really smart database and it generates all of our Kanbans and it generates the QR codes and everything. And that is super slick, and I'd love to get there. The reality is like making that transition while learning about how Kanban works in our shop just didn't happen. Like I wasted a lot of time building a database and then inputting a lot of info, and it was just like, I don't know, there's something to be said for just having a stack of pieces of paper, grabbing a Sharpie, because basically what I did is I said, okay, we're never ordering anything without a Kanban, and so anytime I went to order something, I'd make the Kanban for it, and that's how we did the transition, and it was really easy that way. And I think it would now be very easy to then switch to update
that to be more
a database to say
database.
Like we're never going to order something without a Kanban from the database. And so then you grab the Kanban that exists in Sharpie form.
Yeah.
You enter that info. And I'll say also just like reducing the barrier to entry. I still make Kanbans that don't have all the data filled in. Yeah. Like I'll just write, we need this, like pens. And I don't write a minimum and I don't write a maximum order quantity on it. But already just knowing that we're not going to run out is big. Uh-huh. So I'm just, I guess, encouraging people to try it in a way that, and at a level that makes sense, because all the examples I found online were way beyond, I don't know, what felt like a reasonable lift for us at the time.
Yeah, maybe overkill. Maybe they create more barriers than they reduce sometimes.
Yeah, like you had that with your what's it called, the job management, like scheduling, ERP.
Yeah.
Right. It's like the second it was digital, most of the people in the shop didn't feel like they could change it.
Yeah.
It becomes really daunting to change, and it's actually really helpful to have easy changes.
Yeah. Yeah. Keep coming back to that. Things that are easy to update and edit.
Yeah.
Get used, get improved. Everything else becomes a lot of workarounds.
Yeah, I've seen like a few organizations try to implement like project management software. Uh-huh. And it's sort of this thing of like, we've talked about this in relation to like automation. The software isn't what you're missing in your organization almost 100%. It's like all the processes that make, like the software is automating stuff, but if you don't have those stuffs to automate already well documented, it's just, it doesn't do much. Yeah. Like it has a lot of promise in like, oh, we enter all the data and it notifies everyone when you've completed a task that they're waiting on and all that stuff. And it's like, that's not going to do anything for you unless there's already very clear methods for documenting projects, documenting the steps. And I don't know. I've just never.
Yeah, triggering the stuff.
Yeah, it's like, yeah. It's like, oh, if we buy a new vacuum, our shop will be cleaner. It's like, well, if you're not spending time now cleaning, like, yeah, it will improve the cleanliness of cleaning activities.
Yeah, or reduce potentially the barrier to cleaning.
For sure. I think that's real.
Yeah.
I think that software often doesn't. It does the opposite because now it's another layer of work and
software often
visibility
claim or like appears to reduce the barrier, but sometimes actually increases the barrier.
Yeah, like email reduced the barrier to sending a letter, but it turns out it adds a huge amount of work because of that reduced barrier. Like I found like, not to name names, but like whatever project management software, people end up like, it's really appealing to like build layers deep of like subtasks and sub-subtasks and sub-subtasks. And then, cause I don't know, there's scratches an itch or something. And then something slightly changes in your process and you don't go and update all of those lists. You're just like, okay, whatever.
Yeah.
Set due dates, the notifications start rolling in. You sort of ignore all of them. I don't know.
It's happened.
Building the process in physical, simple methods, like with simple physical methods that are easy to update, I think is often a winning approach.
Yeah. Until it's at, I think once things have evolved and like grown to a high level of maturity.
I think maybe, but I think it's also, yes, but.
I think that's the point at which you can think about transitioning.
I think people's thought about where that level is incorrect almost all the time. Yeah. And the evidence I have for that is that Toyota still runs one of the most efficient warehouses in the auto industry with whiteboards. There is a software back end, like a deep one, but I think it's very tempting. I mean, they have a whole line at their, I forget what they call it, but basically the idea is to come up with very simple solutions to things that don't require power.
Yeah.
And often, I mean, my brother talks about this. He studied electrical engineering and he's like, basically electrical engineering is for lazy mechanical engineering. Right. And that's not always true, but it is often like you see stuff now where they fix things in software because of hardware issues or non-issues. I mean, it's pretty cool, but sometimes it's worth thinking for another 5 minutes of like, could we just solve this by with something really simple?
Reducing a part, removing a part, etc. Yeah. Interesting.
A few other things, and I guess we should kind of wrap up here. So we finally made all the lights turn on and off in the shop on one switch, because we found, like, I found I'd close up the shop, I'd turn off the main lights and realize like a few workstations had their lights on. So I'd turn the lights back on, I'd walk across the shop, turn off those lights, walk back. So that's probably, you know, throughout the week, it probably like 5 minutes of waste, and it's just annoying. And so we've been living like that for 2 years, and it took like $7 of simple extension cords to just plug it into the outlets that were activated on the one switch.
Oh yeah.
Very simple, very awesome. I'm sure there's also like Bluetooth and digital ways of like home automation ways of doing that, which we've done in previous apartments.
Yeah.
But yeah, that was big, and freed up wasted human potential. So now with that, whatever, 5 minutes a week, we can be working on really anything else, and it will be all in, you know, like relaxing, hanging out with friends, or making other improvements. So that one is pretty exciting.
Going outside and staring at the flowers.
Yeah.
As Shigeo recommends.
Exactly. We also added a lot of shelving, which is making me think, why do we need more shelving? But it made the shop a lot more organized, and I think it's going to give us the space to get more organized, and then we might eliminate some shelving.
Yeah, it's always a double-edged sword.
Yeah, like I don't want it to just become more stuff, like places to stuff things. What I'm hoping it does is sort of start to, you know, move things into categories, start to have one place to go to for like stock in the shop, like extra paper towels, pens, envelopes, you know, stuff.
I've started to like kind of to say I'm developing a method would be a far reach, but I'm getting sort of a feel after a decade or so of this kind of thing of like functional, what is a functional organizational system? Yeah. And I think at some point it'd be cool to start actually like codifying it into a set of rules. Because I think people in general have a lot of, like you're talking about, of like the subfolders and the subfolders and the subfolders. Yeah. Like I think that people have that same itch they want to scratch with physical organization.
That's why the Container Store exists.
Right. Yeah. And some of that stuff is really useful, and some of it's a total waste. Yeah. And I do think, I'm like starting to like, it's like coming through the mist, like these vague outlines of like some general rules of like best practices, but they're not complete enough yet to like actually write down. But
or maybe you write them down and keep correcting them.
That's probably it.
I think another piece to this is Yellow Tool in Germany. Really awesome shop tour to watch. One of the things he mentions as I don't know if it's in that shop tour, but is like you have to have a junk room when you're going lean, because the idea is to get like things that are not production related out of the production space. And so you see these shop tours that look ridiculously clean and organized, and you're like, okay, I'm never going to get there, but really they've just shoved their mess into a different room or a corner of the shop. But that is still such a useful thing. It's just like, and so our shop is too small to have like a separate room, but these shelves have sort of like given us enough space to like walk around the shop and be like, this is not production related. Let's get it out of the production area and onto these shelves. Yeah. And then we'll figure out what to do with it. Is that get it sold, donate it? Right. I don't know. Like, I don't know how to deal with like, I mean, we've talked about this, but just like prototyping stuff, or I have a bunch of plumbing fittings, and you could say like, yeah, that's overstocking, which there's an argument for that for sure. But with plumbing, somehow it's like you think you need these fittings and you order them, and then they show up and you're like, oh, dang, I'm one short. Yeah, I don't know. So I still have like a plumbing box, an electrical box.
Yeah. I think that stuff's pretty important, especially in a small organization.
Yeah. And in shop tours, you just don't see it, and no one talks about how to handle that stuff, which is frustrating to me.
Yeah. Yeah, it doesn't probably occur to most people as being important. Yeah. But yeah, also have the idea of having a transitional spot that's like we don't know what to do with this today. Yeah. But we don't want it here. So most people often are like, the options are like, well, trash, like throw it in the trash can or put it back exactly where it was.
Yeah.
Instead of being like, it's going to go here while we figure out whether it's going to be sold or repurposed or given away, or if it's actually going to go in the trash can.
Yeah. I had a funny realization years ago. You know, like a workbench is very commonly covered in stuff that you haven't put away or don't know where to put away.
Yeah.
And I was looking at it, I'm like, of all the places for me to cover in a pile of crap, this is the worst one, right? And it's not super retrievable or organized anyway. So I just made a bin next to my workbench that was just kind of like, you can always just dump stuff in this bin. And I just like took everything off the workbench and stuck it in that bin. And like, I think the issue is that you walk up to a workbench like that and you're like, man, I need to like put everything away. But that's a big enough step or hurdle that it sort of doesn't happen sometimes. So it's similar to that. It's like, if every time you find something that's non-production related in your production space and the options are sort of like leave it there or like list it on eBay, they're just going to stay there. So
what did you do with your bin? Did you do like a weekly clean out of the bin? Like, how'd you handle that? Or was that just it?
It was just a bin, and some things just lingered in there for quite some time. Some things I'd be like, where's that thing? Oh, it's in that bin. That's annoying. Let me get it out. Let me put it away. Or you have an hour where you don't really know what to do, or you're not in the mood to do something else and sort through it. I don't know. It's just like, it wasn't a solution to it wasn't a solution to the problem of I don't put things away. It was a solution to the problem of like, at least let me have a clear workbench.
Interesting. I like it.
Anyway, that's us for the week, I think.
That's all I got. Yeah. Blew my improvement quota on one thing.
On one big thing. That's cool.
Yeah,
I'm excited to hear more about that. Awesome. Well, thanks all for listening. And we will be back next week. You can find some of the improvements and other things on Incremental CI on Instagram. You can find me at Austere_manufacturing on Instagram.
You can find me at Lichen_MFG on Instagram.
And we'll
see you next week.
Take care.